Hello, everyone. So we have another AMC problem. So this is a polynomial problem. So the roots of this third degree polynomial are given three sides of the rectangular box. Okay, and a new rectangular box is formed by the increasing each edge by 2 units. And based on this, what is the volume of the new box? So like whenever you are like somehow question about it related to the roots, you may try finding roots, but in general, we probably don't want to do that because it may not be easier to do that. So like if I want to use like my rational root theorem, so we can take the divisor of -6 and divisor of 10 and see P over Q, which is like numerator will be divisor of the constant and denominator will be divisor of the linear leading coefficient. So that's gonna give us some option to test, but you never know if you're gonna able to get like any rational roots. So if that's not the case, then it's gonna give us no hope anyway. Instead of doing that, I'm gonna just say, let's assume our roots are A, B, C. And then if I have ABC as my roots, right? So the question is asking now, increase those roots by 2 and then multiply together, right? Because we want to find the volume of the new box, which is basically product of 3 sides. So that should be what we are looking. So let's go ahead and multiply these and see what we are looking for. So if you remember how to multiply these, you can just go ahead and multiply it. But like if you multiply A, B, and C, so you just get A, B, C. And if you don't remember, I highly recommend to kind of FOIL these two and then whatever you get from this and multiply with those. But if you do remember, that will be easier. But I'll try to a little bit differently. So if I multiply A by 2 by 2, that's going to be 4A. And if you multiply B by 2 by 2, that's another 4B. So you will get 4 copies of those A, B, C. So I should write that as well. And if I multiply 2 and A, like, I mean, this 2, this B, and this 2, that's going to be 2BC. If I multiply A, B, and this 2, that will be 2AB. So you will get 2 copies of the pairwise product as well. So that should be AB, BC, and AC at the end. So we're going to multiply those 2's as well. So that should be plus 8. Okay, this is what we want, but it looks like you have the product of 3 roots of this polynomial, and then this is the sum of the roots of this polynomial. This is the pairwise product, sum of the roots of this polynomial, so which is kind of a remainder for us to use the Vieta, right? So then I will just say, let's remember this. I'm gonna say, whenever you have like coefficient of, I will say this is A1, this is A2, A3, A4. So 10, -39, 29, and -6. These are my coefficients. So we usually say symmetric sum, which is S1. S1 is the sum of the roots. We just have only one root multiplied by one root, which is just itself. So you just don't multiply, you just write one root basically. So that's why we saw A1. And then we got A plus B plus C. And then this is equal to the negative version of the second highest like coefficient, which is going to be negative of -39 over the coefficient of the leading term, which is going to give us 39 over 10. So let's keep that in mind. And then S2 is going to be the product of the pairwise roots of this polynomial. So that basically AB, AC, and BC. If you multiply this, you will get the next coefficient, which is 29, divided by the coefficient of the leading term, but that's 29 over 10. So in this case, we start with negative. So we are going to have this next one is positive. So that should give us 29 over 10. So when you have higher degrees, you start with negative like first, and then you just make positive next term and then negative after. So if you have like 10 power, so you just cycle those signs basically. So good to remember when you are not sure when it's negative and it's positive. And the S3 is the product of all 3 roots. And that's going to be constant term over leading coefficient. But I said we start with the negative in the S1. This was positive, so this has to be negative. So which is why we are going to have a minus in front. Just keep that in mind. So that will be 6 over 10. So now we are going to just go ahead and plug these into our expression right here. So the product is right here, which is 6 over 10. And then plus 4 times this sum, which is 39 over 10. And the pairwise product is 29 over 10, which has to be multiplied by 2. And there is 8 at the end. So let's simplify. Since we have the common denominator, I'm not going to simplify like these numbers. It will make not good. So 4 times 3 is 12, so which will give us 120. 4 9 is 36, right? And then we get 58. All over these, divide by 10 plus 8. So if I'm at the 38, 6 by 6, which is 42, 42 and 58, that's actually 100. So 100 and 120 is 220. Divided by 10 is 22. Then there is an 8 after, so which is nice actually, because we got a 30. So that is the choice there. So like the reason I kind of like the Vieta, because as you see, we don't really need to find the roots. And what we just need those like expression like A, B, C's, A plus B plus C, and pairwise product and stuff. So it's like really nice because we never try rational root theorem. So if you want to go for it, I guess when you choose x equals 3, it will work out. But until you get that kind of luck, it will take probably too long. And also you may not know if they are actually rational solution, okay? So anyway, I hope that was clear as well. I'll see you in the next video.